In this video, we're presented with a definite integral, the sine of x times the square root of cosine x on 0 to pi over 2. And I'm going to look at two different ways of handling the integral, and I'll call the first one the informal approach. Basically, what we're trying to do is informally do the chain rule backwards. That really is capturing the essence of what a u-substitution almost always is. And then in the second view, we're going to look at the formal approach, where we formally define a substitution for this integral and transform it. So in the informal approach, I'm just trying to recognize that I have a function of a function sitting in this integrand and the derivative of the inner function sitting next to that. And that can be viewed as an effect of the chain rule operating on the expression we differentiate to get this integrand. In other words, the antiderivative we're looking for. So I'm going to rewrite my integral just to make a couple adjustments. And I have a function of a function here. That's the cosine function raised to the 1/2 power. My inner function there is the cosine. And I look for the derivative of that somewhere in the integrand, and I'm really fortunate here because the sine function is basically the derivative of the cosine function. It just needs an adjustment by a minus sign. Well, multiplying the inside of the integral by -1 means I need to multiply the outside by -1 as well. And now I can see the results of the chain rule. I have cosine x raised to a power sitting next to the derivative of it. I can see how this came from using the chain rule on some expression. And my job is to simply guess that expression. Well, cosine to the 1/2 power, it comes from cosine to the 3/2 power. This is just the power rule for antiderivatives, divided by 3/2, in other words, multiplied by 2/3. Now that I've got the antiderivative, I evaluate across the limits of integration. That's from 0 to pi over 2. And when I plug in the upper limit of this thing, I'm going to get cosine pi over 2, which is 0. So that term is gone. I subtract the result I get by plugging in the lower limit, and subtracting this turns it into a positive 2/3. Cosine of 0 to the 3/2, but the cosine of 0 is 1. So I get 2/3 for my integral. Now I highly encourage you to check your answer when you're using the informal approach to an antiderivative. So I want to differentiate this thing and verify that I actually get the original integrand. This is also really good practice on just building your intuition for how the chain rule works. So in this derivative, the -2/3 is a spectator. Then treating cosine x like a single variable, I differentiate cosine to the 3/2 with respect to the cosine function, and that gives me 3/2 cosine to the 1/2. And then the chain rule says you've got to tack on the derivative of the cosine function with respect to x, which is negative sine x. Minus signs cancel, 2's cancel, 3's cancel, and I'm left with what I started with, sine x square root cosine x. So I know my antiderivative was correct. Now in the formal approach, you still have to recognize a function of a function and identify what the inner function is. So cosine x to the 1/2 is that function composition, and the inner piece is what I'm going to let u be equal to. And I've got to have some degree of confidence that I can build the derivative of u in the integrand. So I'm already looking ahead to see if that's plausible. And this looks good because the sine is basically the derivative of the cosine. So I think things will work out. I let u be equal to cosine x. Then du is the derivative of that times dx. So negative sine x dx. And I'm going to transform the limits of integration in this problem. Now, you could transform the whole antiderivative back in terms of x and go from x equals 0 to x equals pi over 2 at the end. I just wanted to illustrate how you can transform the limits of integration as an alternative. So I'm going to say when x is equal to 0, u is cosine x, so cosine of 0, and that's just 1. And my upper limit, when x is equal to pi over 2, u is the cosine of pi over 2, which is 0. So I'm going to make one modification before I plug in all the u stuff. I want to find this du in the integrand, and to do that I need that minus sign on the sine function. And I'll put a minus sign out in front to compensate. Same step I made back here. Now I can sub in everything in terms of u. So I have negative integral, and this negative sine x combined with the dx, that gives me a du. And the square root cosine x, that's just the square root of u. And my lower limit of x equals 0 becomes a u limit of 1, and my upper limit of x equals pi over 2 becomes a u limit of 0. One thing you might want to do here is use this property of integrals, that if you reverse the limits of integration, you get the negative of the original integral. That's not strictly necessary, but I thought it looked nice. And then I simply guess the antiderivative, so I end up with u to the 3 halves divided by 3 halves, which is the same as multiplying by 2/3. And I evaluate from u equals 0 to u equals 1. When I plug in the lower limit, I get 0 out of that. Plug in the upper limit, I get a 2/3, and we've got the same answer. If you find the math content on Zach's Lab helpful, click on the Zach's Lab logo on the right to browse playlists and subscribe to the channel. I produce dozens of new videos per month, and subscribing is the easiest way to find new content. Thanks for watching.